In this video lecture, we're going to be talking about lists in Python, and I'm going to start by first writing down the 5 features of lists that I want you guys to remember. First one is that lists are data structures, not quite data types, and that lists are a collection very similar to strings, and I'm going to add that there are a sequence. So order matters here too. Next, you need to know that lists are iterable, that they are mutable. So strings were immutable, lists are mutable, so I can mutate them without having to redefine them. And finally, lists have their own set of methods and functions that can be applied on top of them. So what I'm going to do is I'm going to contrast what we currently know about strings, and maybe that'll help you sort of see that most of these things are things we already know so far. So starting off, strings were a data type, not a data structure. Strings were also a collection and a sequence collection in that case. So here order matters too. We know that strings are iterable, so I can iterate over them. I can use them for indexing, slicing, everything like that. Strings are immutable, so if I need to make a modification in a string, I'm going to have to redefine the whole variable instead of just being able to modify a little piece of it. And finally, strings have their own set of methods and functions that can be applied on top of them. So let's try to see what things are common here. So we'll notice that you have the collection for strings. Lists are also a collection. They're both sequence, so order matters. The only difference here is that string are a collection of characters. So it could be a symbol or a number, but just one of them. While lists can be a collection of any data type, basically. So I can have a list of numbers, I can have a list of characters and strings, I can have a list of both characters and numbers, and I can even have lists of lists themselves. So you get a lot of freedom when you're using lists. Next thing that's common is that strings are iterable, so I can use them for indexing, I can use them for slicing, and I can use them for like a for loop. And the same thing is applied here too. So lists are also iterable, which means that I can use them, I can index them, I can slice them, and I can use them in a for loop. So this does not change. The notion that strings have their own set of methods and functions and lists have their own set is common too. So the functions you will have for strings are not going to be the same ones that you have for lists, but the commonality is that they both have their individual set of methods going forward. Let's talk about the differences now. So this one is a big one. And the idea here is that a data type basically is a way to store a single value, right? By that, what I mean is that if I need to store the value 5, I know that it's an integer, so I can store it in a variable. Well, if I need to store this string here, I'll be able to store that. So that's a single data type here. With data structure, I'm not really looking to store a single value. Instead, I'm looking to store multiple values efficiently. And by that, what I mean is that let's say I want to describe a shape, and the shape has 3 properties. So the shape has a color, the shape has a color variable, and I'm going to call it red, and I'm going to give it the value. The shape also, let's say, has a sides variable that's telling you how many sides there are. So I'm going to say 4. So it's a 4-sided shape, which is the color red. And let's define an area variable, and I'm going to say it's 12.5 here. So I have defined 3 different variables, and they're all describing a shape, let's say. So the color of the shape, the sides of the shape, and the area of the shape. Well, this isn't quite an efficient way of storing a generalized information in different variables, because they don't really have any relationship within themselves here. It's just how you define them. Whereas in a list, I could say shape is equals to something like this, box brackets, and I could do red. So that's my string here. I can do the number 4, and I could define a value 12.5. So now I will say that shape is a list of 3 values, and you'll notice that all 3 of them are different data types. So you have a string here, an integer, and a float, and I can extract the information using their indexes. So remember, they're still collections, right? So they're both collections here. So the idea is the same. You have this index system going on. So I'm able to say that the 0th index of this shape list I have is going to be the color. Index 1 is going to give you the number of sides, and index 2 is going to give you the area. So instead of having 3 different variables being defined, which are having 3 different data types, I'm able to define a data structure which is able to store information, multiple information, in a more efficient manner. So I can now look at this and say, okay, you have defined a shape variable where your shape list, where you're describing to me what the shape looks like, compared to 3 different variables that are not really in relationship to each other at all. They're not connected. You've just assigned them different names and you're saying that they're connected. So that's where the idea of a data structure comes in. The second difference to know, of course, is that strings are immutable while lists are not. What that means is I was able to define a variable, let's say with the value hello, and I was unable to do something along the lines of this thing. So I'm trying to convert the 0th index value, which is the letter H in my string variable, to a letter G, and Python says that it is not allowed because strings are immutable. I can't mutate them. What I'll need to do is I'll have to redefine the entire thing again to get what I needed. Now, contrast that with lists, and let's say I have a list variable. Contrast that with lists. Let's say I have var to be the list of 1, 2, 3. So it's a list of 3 numbers, and they're all integers. And I can, because lists are mutable, I can do something along the lines of this. What that'll do is it will update the original definition. So I don't need to do var equals 5, 2, 3. I don't need to do that. Instead, what's going to happen is in the original definition of how Python had defined var to be, it's going to update the 0th index with the number 5. Lastly, let's talk about the methods of strings and the methods of lists and how they are different. So I mentioned that this is a commonality where strings have their own set of methods and functions and lists have their own set, but what they're doing, those methods, are very, very different. Because strings are immutable, most methods for strings, they return a new string that has been a new string that has been modified. And so if you've watched the previous videos, you'll notice that the upper method and let's say the replace method, etc., they both are going to apply on the string that you have, and they're going to return a new string that you can either store in the same variable, or you can store somewhere else. But with lists, most methods here will mutate the original list. And so they won't return anything. Now, because lists are mutable, whatever was happening for strings is going to be the complete opposite. With string methods, you're basically looking to return a new string that has the modification applied to them. So if you have a string and you're saying, give me the lower case of it, it's going to return a new string that's going to be the lowercase version of your original string. But with lists, I'm not really looking to get a new list returned back to me. Instead, because lists are mutable, Python is going to apply those methods on that list by itself. So you don't have to worry about you returning anything, but there is now an added concern of making sure that you don't make changes to your list that you didn't really want to have. So these are the 5 main properties or features of lists that I want you guys to be aware of. And now let's look at each of them one by one. Let's start by looking at lists as a data structure. And this is a relatively new term for us, but what it all means is that you're not just storing one piece of information of one data type, but instead you're able to hold multiple pieces of information in just one list variable. So let's define a list. I'm going to call it student, and I'm going to give some values to it. I'm going to give it a string value. I'm going to give it an integer. I'm going to give it a float, and I'm going to give it a boolean. So right away, this is a data structure because I'm able to store multiple information from multiple data types in a single list variable. And then I could go high level and I can say that this is a list of a student's test score. So a student's test score, where let's say this was the name, this is the number of hours they studied, this is the test score they got, and this is if they passed or not. So false means they failed. So not only am I able to store multiple pieces of information, but I'm able to construct a story just for what a list is all about. So I could then have a student2 list, which could then be, let's say, Steve, let's say 3, let's say 42 score, and then let's say this was true. Now I have 2 lists here, and they're both describing a student and their test score using this data structure idea. Now, if you didn't have any data structures, you only had variables, maybe you would do something along the lines of N1 is Rao, and then N2 is Steve, and then H1 is 5, H2 is 3, and then S1, and you get the idea. You're going to have to define 8 different variables to solve this information if you didn't have any data structures. So data structures are really a good way of being able to efficiently store multiple pieces of information into one group here. So because think about it this way, let's say I now have to store the information for 10 students, let's say 100 students. Now in this case, if you were going this by the route of not using any data structures but using variables by themselves, you're going to have to make 400 different variables here. Whereas here I'm only going to make 100 lists. And I'm easily able to extract the information from these lists too, because they're a collection, I have these indexes going on. So I know that for any of these lists, if I were to grab their index 0, so I know that student index 0 is going to be a name, and student 2 index 0 is also going to be a name. Well, here you're going to have to tell me that, oh, n1 is a name, n2 is a name, and n400, let's say, is also a name. So this is a very inefficient way of storing large pieces of information. This is not efficient at all. So let's start thinking about using lists as being pieces to store more information, not just one value or one data type. Because now remember, lists are super cool in that I can make a list of a list. So I could do something along the lines of this thing. Steve 342 true. So now I can say this is a big list, and the index 0, index 1 here, index 0 of the big list is a list of a student. And if you remember the discussion on if a string has multiple indexes in it, and I can slice it down into different substrings, here the exact same idea is that index 0 of the list gives me this sublist here, and an index 1 gives me another sublist here, and then within that list itself, you're going to have their own indexes. So you'll have 0, 1, 2, 3. So a very good way of storing lots and lots of information that are sort of slightly related to each other in more efficient ways. So data structures are really good for doing that. Next, we'll see how lists can be used as a collection. If you recall, strings are collections too, and they are sequences too, but they're a sequence of characters, whereas in lists, let's define our student again. In lists, I am able to store elements of different data types. So this was 5, I think, 23.4, and then a false. And so very similar to strings, because they're still collection. The only difference here again is that lists are able to store multiple data types, whereas strings, so let me say string name is equals to this thing. I'm only able to store little characters, so I can even have an ampersand here, little characters inside two quotation marks. Here within box brackets, I'm able to define even a collection itself. So string here is a collection and different data types. But the idea of indexing and slicing, slicing, and iterating in a for loop remains the same. So by that I mean that I'm able to do student box bracket 2 to extract 0, 1, 2, 3 to extract the test score. So the 23.4 is going to get out. I can replace that with let's say 3, and that would give me if they passed or failed an exam. And slicing works the same way. I can do student, let's do start at the very beginning, and 0, 1, 2. Let's say we only needed the first 2 elements of my list, and I would go all the way to 3, because if you remember, this is not going to be inclusive. So what I will get is another list. Just like when I use slicing for a string, I get a string, I'll get another list out, which will only have the first 2 elements. And you can use the for loop for lists just the same way you would use as strings. So again, because they're both collections and sequences, order matters, things aren't that different here. So I could do for I in student, so iterate over my list student and perform some task. I can do print I, and what that'll do is it will print out this information for me in the terminal, where I will take on every single value. So because I is dynamic, you'll throw that on cursor at the very beginning, and you're going to keep going in that direction where the cursor changes a value every time you iterate. You can also write the for loop the other way. So for I in the range of, now we know of the length function, so I'm going to length of student here, and let's add a colon over here. So what this means, I'm just going to do this first, print I. So what this means is first evaluate the length of the students, and it is going to be 1, 2, 3, 4. So length is 4. So I'm saying run a range function on 4, which will give me 0, 1, 2, 3. So if you remember the range function. And now print I would give you the indices. So it's going to give you 0, 1, 2, 3. And now if I were to modify my code a little, and do student box bracket I, this time around, it will now start printing to me the name, the hours of study, the test score, and then if I passed or failed. So it's telling me for every index I that will take on the value, this value, and in that direction, 0, 1, 2, 3, give me the associated value for that index. So give me index 0 when I is 0, give me index 1 value when I is 1, give me index 2 when I is 2, and then finally the last one, so index 3, which gives us the false here. Let's see lists in action in Atom here, and I'm going to start by first defining a list, and we're going to carry on with our example from the lecture. It's going to be a name. We're going to have 523.4, let's say, and a false. And this is basically how you will define a list, and I'm going to print it out to you too, just to see what it looks like when it's printed. And you'll see the way it's printed, it's still going to have your comma separated values within box brackets here. I can also define an empty list. Just like with strings, you can define an empty string. With an empty list will just look like this. You can just leave it off like that, so you're able to construct and add more to it later. Or let's print that out for you again. Or you can use the constructor for lists, just like the others, to get this here. So again, it doesn't really matter. You can use this thing, or you can just have empty box brackets. Usually I go for the empty box bracket instead of using the constructor function. Okay, so let's look at examples of slicing here. So, or indexing first. And what I'll do is I'll say name is equals to student. Name is equals to student and the 0th index. And I'm going to also get pass is equals to, that's a built-in keyword. So PS is going to be student index 3 because I'm storing the name of the student and if they passed or failed. And I'm going to print out the information by formatting it a little bit. I'm going to say the student name is, and we're going to add name, and they, and did they pass, and I'm going to here add PS. And we're going to run that, and you'll see that the student's name is Rao, and did they pass? False. Okay. Let's try to rework this and instead ask user for the information. So what I'll do is I'm going to remove all this code and we'll start fresh, and I'll say, so we're still going to be looking for 4 different pieces of information. We're going to ask the user for a student's name, the hours of study, the score, and let's say we'll define our own criteria. So we will define our own criteria for if they passed or not. And this criteria is going to be that if the score is greater than 25, then they pass the test. So let's ask the user first and try to construct this list based on that. So I'm going to begin by first asking the user for the name, and I'm going to say input. I'm going to say enter the student's name. Now, you should be able to, if you have seen the strings videos, you should be able to now come up with ways to ensure that the user input is in fact correct using the isAlpha method or something like that. And then I'm going to say the hours of study is going to be the int version of the input. And I'm going to say enter the hours they studied for. And finally, I'm going to store the score in a float variable, and what was their score. Okay, and let's run this code. And what I'll do for now, just to test things out, and I'm going to print the name, the hours, and the score. Okay, enter the student's name. It's Rao. The hours studied was 5, and their score is 23.4, and you get that printed out. Now, a really easy way of making this into a list, of course, is to just put box brackets around it. If you know what goes into your list right away in the very beginning, you can just put box bracket around those variables, and you'll see something like this. So I'm going to rerun it with the same examples, and now you'll notice that a list is being printed out instead of the values. Okay. This works. So now we'll test our criteria, and I'm going to say that I'm going to define a variable PS, and for now I'm going to give it the value true. This is a placeholder, and then we'll say that if score is greater than 25, PS is true, else PS is false, right? Now you can very much, you can make this very much more efficient, and you can just have one if statement by making this false. You don't need the else part there then, but let's stick to this. And then we can finally make a student list to be name, hours, score, and if they passed or not. And I'm going to print student at the very end. So let's run this again, enter the name, the hours of study, the score was 23.4, and you'll right away notice that you get a list printed out where we also were able to store if they passed or not in there. So pretty easy generating strings lists like that. In terms of slicing, let's say I want to not have the pass-fail attribute in my list. So in that case, what I'll do is I will print student, and then in box brackets, remember slicing, I'm going to start at the very beginning. So I could put 0 here, but I don't need to, because if it's empty, that just means go from the very beginning. And I want to have index 0, 1, and 2 there. So I'm going to put the value index 3. Index 3 currently is telling us the pass-fail attribute, but remember, the ending value is not included here. So let's do that again, 23.4, and there you have it. So you sliced through your list and only got the first 3 elements and not the 4th one. So very, very similar to how you would do things with a string. Let's also look at how we'll use our list in a for loop, and I'll write down 2 different ways of doing it, and I'm going to comment out all the print statements for now. And so the first one is going to be very typical for I in student. So the variable I dynamically is going to take on every single element of my student list. So it's going to become row, then 5, 23.4, and then false. And let me just print them out to you. Let's run this again. 5, 23.4, and you get the name. So I becomes the name, and then it becomes the number of hours of study, the test score, and then whether or not they've passed or failed the class. I can also write a variation of a for loop here. So let's first use the length function. So in the range, I'm going to do for I in range of the length of student. And remember, the length will be evaluated first, and length of student is basically how many elements are currently in that collection, which is 4. And then I'm going to run, Python is going to evaluate the range of 4, which basically means start at 0, 1, 2, and 3. So just basically all the indexes inside my list. And I'm going to print I, and I'm going to also print the student of I. So I'm printing the index, which is going to be 0, 1, 2, and 3, and then the element of my list student at that index. So running it all again, we'll get this. So at index 0, I had the name. At index 1, I had the number of hours of study. Index 2, the test score, and then at index 3, whether or not they passed or failed the class. The last thing I want to go over in this video is list as mutable. And this is again a new idea here, because when we looked at strings and we realized that we're unable to modify a single element within a string, or even multiple elements within a string. So I can't even do this. So this is me saying replace the first 3 elements within var with ABC. That's also not possible because strings are immutable. Well, because lists are a data structure and Python wants you to use them as efficiently as possible, they also allow lists to be mutable. So if your student list had a name, it had the number of hours of study, and a floating value, and then this, let's say that your criteria of evaluation if they pass or fail changed. So right now we were saying that if the score is greater than 25, only then you pass the class. But let's say that some extra credit or a curve happened, and instead you're now looking at if the score is greater than 22 or not. Now in that case, Python doesn't want you to do this. Python wouldn't like that if you were to go back and redefine the whole thing. 20.4 and false. Instead, so you'll then say that this is in fact going to be true. What you'll say now, let me fix that. What you can actually do is then say, take the last index of my student. So you could have -1 here, or you could just do 0, 1, 2, 3. The index 3 of my student is now true. And what's going to happen is that, so let's make our favorite block of memory here. And if in memory you had a reserved space for student and the information that's being stored for a student, so 2.4 and false here, and this is the memory block for your student list. After you run this line of code, after you say that change the index 3 value of student list to true, Python will go back to the original memory and replace the value. So you won't have values redefined. Instead, it will go and mutate. So that's what the mutable means. It's going to mutate the original list. And that makes lists all the more powerful when you're dealing with them. So I've defined 2 different lists here, student 1 and student 2, and we're going to try to see if we're able to update their pass-fail status based on a new criteria. So the new criteria again is that if you score greater than 23, you pass. So in that case, Steve should still be a true on the pass, but Rao's status should change to true again. So I'm going to add a more complex step here, but don't get spooked by what's happening here. Student 1, student 2. So I know for a fact that student 1 and student 2 are both lists, but now I've made a new list called students that is a list of the 2 lists. So if I were to print this out to you, you're going to see something like this. So you're going to start off with 2 box brackets at the very end, and then within which every element is itself a list. Okay, and let's make things clearer. So if I were to print the index 0 of students, take a moment, pause the video, and try to figure out what that will be. And if I run this, it should give me the entire list, student 1 list, from index 0, because my list my list students is currently made of 2 different elements, and it just happens to be, coincidentally, that those 2 elements are themselves lists. So me doing students box bracket 0 is me saying, give me the first student list from this big list. And then I can also, now here's some spooky stuff, I can also do, let's say this. So I've added a box bracket index 3 after students box bracket 0. So remember, evaluate things first. So this guy is going to be the first element, which is a list. So I am very much able to then do a box bracket and index an element within that list. So in this case, what I'm trying to print out is the pass-fail status of the first student, so index 0 student in my list here. And try to play around with different values here. So I'm going to replace this with 1. What I mean by this is now give me the status, the pass-fail status of the student at index 1 here. So for Steve's, and you'll see that it is a true. Now, I could be a little cheeky here and instead do this and then add another index. Now, this is getting more confusing, but if you're able to sort of figure out what it means, then you're really good to go. You have now understood strings and lists, basically. So let's see what's happening here. So from students list, which is made up of 2 lists, give me the element at index 1. So give me Steve's information, and then go to the 0th index of Steve's list, which is the name. Okay, and we know that the name is a string and strings are a collection. So for those collections, I am also able to do indexing and slicing. Then I should be able to then do index 0. So all in all, this should give me the first letter of a student whose list is at index 1 in this big list. you can go back and revisit this again and sort of, again, change these values, try to see what else you can get to. Okay, I'm going to remove this spooky stuff, and then we're going to continue now and use a for loop to then update the value of a student if their score is actually, in fact, greater than 23. So I'll do for I in students. And again, if I were to print students here, you'll notice that it is giving me, I is taking on the value of each list one by one. Okay. And again, I am trying to figure out what their score is. So let me store that information here. So I'm going to say score is equals to I. And if I is a list, I am looking for the score, which is at index 0, 1, 2. So we know for sure that this is what the index is going to be. And then I can do something along the lines of this. I can then say print score. So what should be happening here is we're only should be getting 23.4 and 42 printed for our lists, for our two student lists here. And you get 23.4 and 42. Okay, so we have the right score. And now I'll say that if the score is greater than 23, I want to print you should pass. Now, we had Rao's no pass value set as false here, but we want to update it. And this should say you should pass for both. Okay, so we can now go ahead and say that if the score is greater than 23, then this current list that I'm at right now, the ith list, I want to change the status, the true and false value, and it is at index 3, so 0, 1, 2, and 3. 2, true. And let's see, let's print students at the very end and see what happens. So again, for every student list in students, because my student is made of this list of students here, find the score. And if that score is greater than 23, then update their status value. So if they scored more than 23, their pass no pass status should be a true. So let's see what happens here. And now you'll notice that I didn't actually go back and redefine student 1 again, but you'll notice that now my student list shows Rao with a status true and Steve as was. So just to confirm things, let's define a new student. Let's define Jack, and let's say Jack's 1 hour, and he got a score of 10, and he was in fact a false, so that he did not pass. But let's say if it goes through our system here, our code, and I'm going to add student 3 here, and I'm going to print students, and I'm going to also print a dashed line here just to differentiate. And if I run my code, okay, so this was before I made any changes. So you'll notice that Rao has failed the class, Steve has passed, Jack has failed. But because Rao had a score of 23 and more, based on our criteria, Rao's status is updated to true, Steve's remained the same, while Jack's still remains false because he only scored a 10. So try playing around with this little test bed here and see if you're able to add more students or able to do a lot more in this for loop. In this video lecture, we were able to look at the first 4 features of a list. So the fact that they're data structure, they're a collection or sequence, they're iterable, and they're mutable. In the next lecture, we'll look at some of the main methods and functions that we can use on our lists.